Hello, this is Mr. Collier, and today we're looking at the first derivative test. So here we have the sketch of a function. I'm going to assume it stops here and stops here because there's no arrows. You can see we have a couple of maximums here. This one's called an absolute maximum or global maximum because it's bigger than all the other points in the entire function. And this one's called a relative maximum. And then we have some minimums. Here's a relative minimum. Okay, and here I'm not sure which one's bigger, maybe, or I think this one's smaller, so we'll call this one the absolute minimum, and this is a relative minimum. Or if they're both the same, then we'd have two absolute minimums. Okay, so you can see these minimums and maximums, they occur when the derivative equals 0, because these tangents are horizontal. So the derivative could be equal to 0. Or here actually is a sharp point or a cusp. That means the derivative is undefined because you can draw many tangent lines through that one point. Okay, and also they can occur at the endpoints, and the derivative is also undefined at endpoints. So a critical value of a function is where the derivative equals 0 or where it is undefined. Okay, because that's where a maximum or a minimum could occur. So we call it a critical value. It's not necessarily a maximum minimum. Like for example, the function y equals x cubed has a derivative equal to 0 right there, but that is not a maximum or a minimum. So it's possibly a maximum or minimum. So we call that a critical value. Okay, we're going to look at this function, find the critical values, and hence find the intervals of increasing or decreasing. Okay, so to find the critical values, now first of all it's defined for all x, so there's no places where the derivative is going to be undefined. Let's find the derivative. I'm going to multiply this out first. So this is 4 x to the power of 3 over 5 minus x to the power of 8 over 5. If I expand the brackets, so the derivative is, you're going to have 4 times 3/5, so you're going to have 12/5. X to the power of, reduce the exponent by 1, we get negative 2/5. Okay, and this part here, we're going to have minus 8/3 x to the power of 2/3. Sorry, that's not 8/3, that's 8/5. So this is going to be 3/5 when I subtract by 1. Okay, so next we're going to set the derivative equal to 0 to figure out any critical values. And we want to simplify this a bit to be a bit easier. And we've got these fractional exponents. What we could do is actually we can multiply both sides by something to get rid of these fractional exponents. That number would be x to the power of 2/5. If you think about it, yeah, negative 2/5 plus 2/5 is 0, and 3/5 plus 2/5 is 1, so that will make everything nice. And let's multiply by 5 as well to get rid of the 5 in the denominators. So this will be 12 x to the power of 0, which is just 1, and this is going to be just 8x. So we have 12 equals 8x, and x equals 1.5. Okay, so that's a critical value. So it's possibly a maximum or a minimum. Hence find the intervals of increasing or decreasing. So what we can do is we can look, so it's defined everywhere, and this is the critical value. This is the only place where it can possibly change from increasing to decreasing. So we'll look at values of the derivative to the left and to the right of 1.5. Okay, an easy number to plug into the derivative is 0, right? So 0 is to the left of 1.5. If I plug in 0, well, I'm just going to get 0, so that's not actually helpful. So let's plug in 1. If If I plug in 1, I'm going to have 12/5 minus 8/5. I'm going to get a positive number. So it's actually increasing to the left of 1.5. Okay? So possibly it's a maximum. And over here, I plug in maybe 2. If you plug in 2, or yeah, I guess we'll probably have to use a calculator for that one. So if I type it into the calculator, I get a negative number, so it is actually decreasing right here. So it increases and then it decreases. That's a maximum right there. It's going to be a global maximum. Okay, because it's the only place where it changes from decreasing to increasing, or increasing to decreasing. Okay, so it is decreasing. It is increasing. You can say for x less than 1.5 and decreasing for x is greater than 1.5. Okay, hence the maximum or minimum point. So find the minimum or maximum point. So this is 1.5, and you can plug into your calculator, plug in that x value to get into the original function to get the y value. I'm going to show you what the graph looks like on Desmos. So here it is on Desmos. So it's increasing, 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 and then it's decreasing after the point 1.5. So the y value looks like it's about 3.19. So the maximum is at 3.19. Okay, so yeah, so if you want to figure out if it's a local minimum or local maximum, you need to test points to the left and to the right. If it goes from positive to negative, that means it's increasing, then decreasing, then we have a maximum. If it's going from negative to positive, then it's going from decreasing to increasing, so we have a minimum. Okay, and sometimes we have what we call a horizontal or stationary point, a horizontal inflection point or a stationary inflection point, like y equals x cubed has that point. Okay, so if it's positive, then it's not a maximum, or and negative is not a maximum or a minimum. Okay, we have a situation like that. Okay, next we're going to look at this one with a sine function. Find the absolute minimum and the absolute maximum of this over this domain. Okay, so if the domain is restricted, it's got to have absolute maximum or absolute minimum if it's including the endpoints. Okay, state your answers exactly and check your answers with the GDC. Okay, so the derivative is 1 minus 2 cosine x. Okay, so if we have 1 minus 2 cosine x and we set that equal to 0, we can find the critical values. Okay, so we have cosine x equals half, and we're looking at this full range of 0 to 2 pi. Oops. So where is it equals half? It equals half in this quadrant and this quadrant. The triangle we're talking about is this one. So this is pi over 3 is going to be that. So x equals pi over 3 is this one. And x equals 2 pi minus pi over 3 is going to be this one right here, which is 5 pi over 3. Okay, so those are our critical values. Also, you have to check the endpoints, see if there are maximums or minimums. So we need to check check all of those values. We can actually just plug in these values and check them all. Okay, so let's make a diagram of this, x and an f of x. So we need to check 0, pi over 3, 5 pi over 3, and 2 pi. And plug those into this function right here. So we have 0, what's sine 0? Sine 0 is 0, so this is 0, 0. we have pi over 3, then x is going to be pi over 3. Sine pi over 3 is root 3 over 2, times 2 is root 3. So this is going to be 1 minus, or pi over 3 minus root 3. And this one here, sine 5 pi over 3, that's going to be negative. And it's going to be negative root 3 over 2. So we're actually going to have 5 pi over 3 minus 2 times root 3 over 2 is plus root 3. So that looks like it's going to be a maximum because it's bigger than this one. Let's see what happens with 2 pi. Sine 2 pi is 0, so we just have 2 pi. Okay? So if you check this on your calculator, this one's bigger than this one here. So this is the maximum, the global maximum. Alright, it's the point 5 pi over 3, comma 5 pi over 3 plus root 3 is the global maximum. And the smallest, if you check on your calculator here, I believe this one is less than 1, so this is the minimum. Okay. Okay, so let's check on Desmos, just see what the graph looks like. Yes, so we have a minimum right here at pi over 3, and that's negative, yeah, it's 0.68. And there is the maximum over here at 5 pi over 3. Okay, so that's your maximum and your minimum. Okay, next example, we're going to be differentiating this one and finding out where it's increasing, decreasing, and stationary. So the derivative is 3 times a third, so that cancels nicely, plus 4x minus 12. And we'll set that equal to 0 to find out where it's increasing and decreasing. So 0 equals, and this factorizes to x plus 6, x minus 2. So our critical values are 2 and negative 6. So negative 6 and 2. Let's find the derivative when x is like 0 is in between these two numbers. If I plug in 0 here, I'll get 6 times negative 2, so that's going to be negative. If I plug in a number bigger than 2, like 3, you're going to get a positive number. And I didn't leave much space, but I need a number smaller than negative 6, so that will give you a negative, oh, that'll give you a positive, because you have negative times negative is positive. Okay, so it is increasing when x goes from negative infinity to negative 6, not inclusive, union 2, comma, infinity. And decreasing on the interval between negative 6 and 2. Negative 6, comma 2. And it's stationary at x equals negative 6 and 2 because the derivative is 0 there. Okay, next example, we're going to have to use quotient rule to find the derivative. So this is going to be the derivative of the top is 2x minus 1 times the bottom minus the derivative of the bottom, which is 2x minus 1 times the top over the denominator squared. Now, before you start multiplying everything out, you're going to get a cubic if you do that, so it's not going to be very easy to work with. Notice you have a 2x minus 1 in both cases, so you can actually factor that out. So I factor out 2x minus 1. Inside the brackets, I've got x squared minus x minus 6 minus x squared minus x. And the denominator stays the same. Okay, so the numerator, we've got 2x minus 1 times now x squared minus x squared, that just cancels, and then we got negative x minus negative x, so that cancels, so we just have negative 6 actually. Okay, so then on the denominator we have, this still. So this equals negative 12x plus 6 over x squared minus x minus 6 all squared. Okay, so to find out where it's increasing or decreasing, we need to set this equal to 0. And if we set this equal to 0, then we can multiply both sides by the denominator, and it's times 0, so it's just gone. So we just need to look at the numerator and whether the numerator is positive or negative. Okay, from this we get 12x equals 6 and x equals half. Okay, that's our critical value. So we'll check to the left and right of half. Okay, so we'll plug in maybe 0 into the derivative. If we plug in 0, we get positive 6, or so it's positive. The denominator is always going to be positive, so we just need to look at the numerator. If we plug in a number like 1, we'll get a negative number. Okay, so where it's increasing is increasing when x is less than half, and decreasing when x is greater than half.